Okay, I just want to take a look at lesson 3 and look at some of the patterns that we can develop. So if you look at the tens pattern, 10 to the power of 3 is 1,000, 10 to the power of 2 is 100, 10 to the power of 1 is 10, 10 to the power of 0 is 1. We did that the other day. Because as I move down this line, I keep dividing by tens. So if I keep dividing by tens, I'm going to get 1/10. If I take 1/10 and I divide it by 10, what do I get?
100.
And if I divide it by 10 again, I will get 1/1000. If I look at my exponents keep decreasing by 1. So that 10 to the power of -1 becomes a 1/10. And if I write 10 as a power, it's 10 to the power of 1. Again, going down the line, -1 to -2. This becomes 1/100. If I take 100 and write it as a power of 10, it's 10 to the +2. And if I take 1,000 and I write it as a power of 10, it's 1/10 to the power of 3. So this 10 to the -3 can be written as 1/1000 or 1/10 to the +3. If I look at my 3's, I have 3 to the power of 3 is 27, 3 to the power of 2 is 9, 3 to the power of 1 is 3. I'm dividing by what each time?
3.
I'm dividing by a 3 each time. So if I take 3 and divide it by 3, I get 1, which is what we looked at the other day with our 0 exponent. If I take 1 and I divide it by 3, I get 1/3. If I subtract my exponents, I now have a -1. Subtract my exponent again, I get a -2. If I divide by 3, what is 1/3 divided by 3? Say it louder. 1/9. And if I divide 1/9 by 3 again, 1/27. And if I rewrote these as a power of 3, I get 3 to the power of 1. If I take 9 and I write it as a power of 3, I get 3 to the power of 2. And if I take 27 and I write it as a power of 3, I get 3 to the power of 3. So we have 2 columns of patterns. And then we have a column that has variables. So I don't have any numerical value to associate to these. However, in looking at the pattern, if 10 to the power of 0 is 1, and 3 to the power of 0 is 1, a to the power of 0 would be 1 as well. If 10 to the power of -1 can be written as a 1/10 to the +1, and 3 to the power of -1 can be written as 1/3 to the +1, what can I do with a to the power of -1?
1/8 to the 1.
1/8 to the +1. 10 to the power of -2, I rewrote as 1/10 to the +2. 3 to the power of -2, I rewrote as 1/3 to the +2. So a to the -2, I could rewrite as
1/8 to the power 2.
and then how would I write a to the -3?
1/8 to the 3.
1/a
Cubed.
cubed. So if part B says write the following with positive exponents, how do I take 10 to the -7 and write it as a +7? 1/10 to the +7. If I have 3 to the power of -5, how do I make that a +5? 1/3. And if I have a to the power of -n, where n could be whatever value I want to give it, how would I make that a +n?
1/8.
1/a. I might have time to, no, we'll stop there. I said it'd be very short. Okay, so what we were looking at yesterday with our negative exponents is we were just completing the patterns. If I keep dividing by 10, I get 1/10, 1 100th, 1 1,000th. The pattern that we saw was that the negative exponent I could write as 1 over the positive exponent. And that's what we were writing in part B. I can take a to the power of negative n, and I can write it as 1 over a to the positive n. So if we use our exponent laws, 5 to the power of 4 divided by 5 to the power of 7. If I use my calculator to do this for me, tell me what you get. So go 5 to the power of 4 divided by 5 to the power of 7. And tell me what you get as a decimal and as a fraction.
Decimal 0.08.
So that would be 8 thousandths.
And as a fraction is 1 over 125.
So if we were to use our exponent laws or our knowledge of exponents to expand this out, 5 to the power of 4 is 5 multiplied by itself 4 times. And 5 to the power of 7 is 5 multiplied by itself 7 times. What did we say about 5 divided by 5? It equals 1, it cancels out, it crosses out. So I can cancel out. I can cancel out 4 on the top and 4 on the bottom. That would leave me with a 1 on the top and 5 multiplied by itself 3 times on the bottom. 5 to the power of 3 is?
125.
So I get the same answer as I got with the calculator. If we use our quotient law says if the bases are the same, I subtract the exponents. 4 minus 7 is negative 3. So 5 to the negative 3 has to be the same as 1 over 5 to the positive 3, because these values have to be the same. So this gives us a general rule. When a base is raised to a negative exponent, for example, a to the power of negative p, I can write it as 1 over a to the power of a positive p. So if I had 2 to the power of negative 1, how would I make that a positive exponent?
1 over 2 to the power 1.
And what's 2 to the power of 1?
2.
So this would give me 1/2. If I had 3 to the power of negative 2, how would I make that a positive exponent? 1 over 3 to the power of 2. And what's 3 to the power of 2? 9. So this becomes 1 over 9. And if I have 4 to the power of negative 3,
1 over 4 to the power of 3.
and 4 to the power of 3 is,
64.
so I get 1 over 64. And you can use your calculator to verify these. Use the rule for the division of fractions to show that 1 over 4 to the power of negative 3 equals 4 to the positive 3. So let's start off with, what do I know about 4 to the power of negative 3? How can I make that a positive exponent? That'd be 1 over 4 to the positive 3. So in this equation, this 1 divided by 4 to the negative 3, I can rewrite it as 1 over, or 1 divided by 1 over 4 to the power of 3. What is my pattern for dividing fractions? How do you divide fractions? So if I have 2/3 divided by 4/7, how do I divide? So what does that mean? Flip and multiply. Which one do I flip? Both, or the first one, or the second one? The second one. So if I use that pattern, this dividing, this 1 divided by becomes a 1 multiplied by, and I flip this. Well, if I take 1 over 4 to the power of 3 and flip it, I get 4 to the power of 3 over 1. Do I need this 1 on the bottom? Nope. And 1 times 4 to the power of 3 becomes 4 to the power of 3. So 4 to the power of 3 I know is 64. On your calculator, what I want you to do is go 1 divided by 4 to the power of negative 3 and tell me what you get.
60.
I get 64. So now we're going to go through a series of examples, all sorts. The examples are based on the negative exponent law. The negative exponent law says a base, not including 0, so a base raised to a negative exponent has the following properties. If it's a to the power of negative n, to make it a positive n, I go 1 over it. If it is already 1 over a to the negative n, I flip it, and I get the positive n. So I'm flipping this each time. This is the same as a over 1. So I flip it, and I get 1 over a. If I have 1 over a, I flip it, and I get a. So all I'm doing is flipping it each time. I'm taking the reciprocal. My negative base becomes positive. Or in other words, if my base is negative on the top, it's going to be positive when I move it to the bottom. If it's negative on the bottom, it'll be positive when I move it to the top. So class example number 1, we are going to simplify these, make sure that they all have positive exponents, and then evaluate them without the use of a calculator. So if I look at A, bases are the same, I'm multiplying, what do I do with the exponents? Add them together. 5 plus negative 3 is 2. And what is 4 squared?
60.
If we take a look at B, I've got 3 squared times 3 to the power of negative 5. I'm multiplying, means I add the exponents. If I add the exponents, what do I get? So I get 3 to the power of negative 3. How do I write this as a positive exponent?
1 over 3.
And what is 3 to the power of 3? 27. Okay? 2 to the power of negative 5. Or sorry, 1 over 2 to the power of negative 5. How do I make that positive? Say that louder, Kate. 2 to the power of 5. And then if I have to evaluate it, 2 times 2 is?
4.
Times 2?
8.
Times 2?
16.
Times 2? 32. Okay? If we look at D, 6 to the power of negative 7 minus, or divided by 6 to the power of negative 5. I subtract the exponents. Negative 7 minus a negative 5
Negative 2.
gives me negative 2. How do I make that a positive 2?
1 over 6 to the power 2.
And what is 6 squared?
36.
So I get 1 over 36. In E, it's the power to a power. So if I'm raising a power to a power, what do I do with my exponents? So So if I multiply them, I get 2 to the power of, and how do I make that a positive 3? 1 over 2 to the positive 3. And what is 2 to the power of 3?
8.
I can't prevent you from using a calculator on a test, but this is almost as fast as using the calculator and less likely to make mistakes. Class example number 2. True or false? 8 to the power of 3 divided by 8 to the power of negative 1. What do I do with my exponents? So if I say 3 minus negative 1, what do I get?
4.
So is this true or false?
True.
True. Okay? If I look at B, three minus negative 1 is 4 because we figured that out in the first one. But what, Jonathan?
The different bases.
Different bases, so is this true or false?
False.
And the reason why it's false is there's different bases. My rule, oops, not different rules, different bases. My rule only works for the same base. It doesn't work for different bases. C, true or false? True. And D, is that true or false?
That's false.
Why?
Because of the 9. You have to multiply.
Yeah. The 9, oops.
The nine is separate.
Because it was
The 9 doesn't have a negative exponent to it. So the 9 should stay exactly where it's at. The 9 should stay on the top. And only the A should go to the bottom because the A has the negative exponent. So this becomes false. Good. That's impressive because a lot of times the first time I do that, everybody's like, no, it's true. The 9 does not have the exponent.
9 is multiplied.
If it was this, oops, not 1 over. Would the 9 move to the bottom? Yes, because that negative 3 goes to both. Okay, so see the difference between the two? So what I'm going to get you guys to do is I'm going to get you to do class example number 3. It's not much different than 1 and 2, except I have the introduction of my variables. It's still the same rules. So I still would do the coefficients, I would still do everything else the same, just if I have negative exponents, I would move them down. So I'll give you about 5 or 6 minutes to work on that. So let's look at these. If I have a to the negative 4 times a to the negative 3, add the exponents and I get a to the, and then as a positive exponent would become
1 over 8 times 7.
So if I look at B, I have coefficients and I have variables or powers. So I divide the coefficients. 6 divided by 2.
3.
3. Then if I take my x's and I use my power or my quotient law, 2 minus 7, negative 5. How do I make that a positive 5?
3 over x.
Yes. So the 3 stays up top because it doesn't have the negative power to it. With C, that 2 is going to stay on the bottom because it does not have a negative exponent, so it's going to stay right where it is. If I subtract, because this is a division, 6 minus negative 5,
11.
so it becomes y to the power of 11 divided by 2. Or I could write it as 1/2 y to the power of 11. Okay, what happens with D?
I got 1 over 2x to the power of 3.
It'd still be a negative. So this negative here would still stay. It's this negative that becomes positive, not the negative on the coefficient. So negative 2 to the power of 3. Negative 8. And then x to the power of 3. Typically, I would not leave my negative in front of the 8 like that. I would bring it out in front or to the top. And that comes just from what does this represent? Well, this represents what do I divide the whole into. So if I have like a whole pizza or a whole product and I'm dividing it into pieces, it doesn't really make as much sense to divide it into negative pieces. The negative on the top could represent taking one of them away, but it's easier to think of my whole pieces as having, or my fraction pieces as not having a sign to them. Okay, if we look at E, 8 divided by 4. 2. And then what happens to the 8 to the power of negative 5?
A to the positive 5 on the bottom,
Yep,
and then B to the positive 3 on the top.
they just switch places. So if B is negative on the bottom, it's going to be positive on the top. The power of A is negative, it's going to be positive on the bottom. Okay, what would I do with F?
Just switches.
Where does the 5p go? It's going to go to the bottom. Where does the 5q to the power of 4 go?
5 would go to the top.
Would the 5 go to the top?
No, it's not negative.
There's no negative exponent with the 5, so it's not going to move. Is the q going to move? It's going to stay right where it is. So what do I put up on the top now? A 1. So what is 5 squared?
25.
And if I take 25 and I multiply it by 5, what do I get? 5 quarters.
It's 125.
125. And then p squared q to the power of 4. Okay, 2 more examples. So question 4 says simplify and write the answer with positive exponents. So I've got a division of a division. So let's simplify this first. So if I simplify this part first, subtract 8 minus 5,
3.
that should be equals, that should be divided by. So 15x cubed. If I subtract 3 minus negative 3, 6. And then negative 1 minus 2.
You put the Z on the bottom, the power of 1.
I'm going to wait to put everything on the bottom until I combine it with this. So for now, I'm going to leave it as a negative exponent. So I would get z to the negative 3. Just because I still have to divide this part. So what I could do is I could write this now using a division bar. What happens when I go the 15 divided by 5? I'm going to get a decimal. So can I divide 15 and 5 by a common factor?
5.
What's 5 divided by 5?
1,
Okay, and 15 divided by 5?
3.
3. So I'm not going to worry about putting the 1 on the top unless I have nothing left on the top. So my x is x to the power of 3 divided by x to the power of 3.
Then you cross it out.
They're going to cross each other out. They're going to cancel each other out. Then I have y to the negative 8 divided by y to the positive 6. So subtract the exponents. Negative 8 minus 6.
2. Oh, no.
Negative 8 minus 6. If I'm at negative 8
Negative 14.
and I subtract, that means I'm stepping backwards.
It's
Negative 14. And then negative 2 minus negative 3. It'd be 1. But that negative 14 needs to be made positive. So I move it down, and the z stays up. There is another way we can look at this where we can kind of go from this step to this, which some of you might have already did when you went y to the negative 14, put it on the bottom. The other way I can look at this is subtract the biggest number by the smallest number. So if I look at my 6 and my negative 8, 6 is the bigger number. So then subtract this way. 6 minus negative 8 gives me 14. Because I started down here, I stay down here. Negative 2 is bigger than negative 3, so I subtract this way. Negative 2 divided by negative 2 minus negative 3 gives me a positive 1. Because I started on the top, I stay on the top.
I don't understand how you get, how you get to 3 and,
This 3,
yeah.
5 divided by 5 is 1. 15 divided by 5 is 3. Or if I go 15 divided by 5, my calculator gives me 0.3 repeating, which is 1/3. So I just didn't put the 1 in front. There's my 1/3. Does that help? A little? So I'm just reducing the fraction because the fraction doesn't divide nicely. It's not like when I had 8 divided by 2. Explain why 2p to the power of negative 3 is not equal to 1 over 2p to the positive 3. Because 2 does not have the negative exponent. So it should actually equal 2 over p to the positive 3. Okay, I want to quickly look at that one question. I'm going to take this one. When I looked at this question, the b became positive when I put it on top. The a became positive when I put it on the bottom. And when I say the b became positive, I mean the exponent. Okay? If I went like this, a to the negative 4, b to the negative 4, they're both being raised to the same power. So would that be the same as writing it this way? The 4 would go to both parts. These are still equal, right? But what we did say is the b becomes positive when I put it on top. The a becomes positive when I put it on the bottom. So if I wanted to go from here to make this a positive 4, the b goes to the top, the a goes to the bottom. All I do is flip it, which is what I've done all along. I've flipped it each and every time. So if I have, let me get a blank page. when I had a to the negative 2, this was the same as a over 1 to the negative 2. And when I flip it, I get my 1 over a to a positive 2. What's 1 squared? 1. We ignore this part because 1 to any power is going to be 1. It doesn't change anything. The only time I have to be careful is when I take something like this. Now I no longer have 1s. To make this a positive 2, I still flip it. So 5 over 7 to the power of negative 2 is the same as 7 over 5 to a positive 2, which becomes 7 squared over 5 squared, or 49 over 25, which you can check using your calculator. Go bracket 5 divided by 7 to the power of negative 2, and change that answer to a fraction. It'll be 49 over 25. So if we go back to the bottom part of that page, consider the expression 2/3 to the power of negative 4. 2/3 to the power of negative 4 is the same as going 1 over 2/3 to the positive 4. My fraction rules say that it's the same as multiplying by the reciprocal. Oh, sorry. Okay. So this part here, they just evaluated. So if I take this as 1 divided by this fraction, it would be multiplying by the reciprocal of that fraction. And I would get 81 over 16, which is the same as 3 to the power of 4 over 2 to the power of 4, which is actually what part B is. So is this statement 2/3 to the power of negative 4 equal to 3/2 to the power of 4?
Yeah.
This is true. So if I have 5/2 to the power of negative 3, how would I evaluate that without using a calculator?
2 over 5 to the power of 3.
Which then becomes 2 to the power of 3 over 5 to the power of 3. 2 to the power of 3 is,
8.
and 5 to the power of 3,
125.
which brings us to